In today's screencast, we are going to look at the power of compound interest. The first problem, for those of you that have Using and Understanding Mathematics, a Quantitative Reasoning Approach by Bennett and Briggs, is number 57 on page 244. Deals with money that's deposited into an account with an APR of 7%. Interest is compounding monthly for 15 years. For this problem, we're going to use the formula that you see in the middle section of the left-hand side of your screen. You'll notice, depending upon the textbook that you use, that some of the variables are named a bit differently. Let me explain what these variables represent before we start in on our first problem today. A stands for accumulated balance. That's the future value of the account. If we don't touch the money, we don't touch the interest, what will be there after 15 years? P is the starting amount that we're going to deposit, also known as the principal. And yes, it is principal spelled with P-A-L on the end. The second is the annual percentage rate. For us, we have an annual percentage rate of 7%. That, however, we are going to have to turn into a decimal before we proceed. N stands for the number of compounding periods each year. Since we are compounding monthly in this particular problem, that will be equal to 12. And Y equals the number of years. In some formulas, rather than using Y, they use T for the number of years. Also in some other formulas, instead of using APR, they'll just use a lowercase r for interest rate. Those are the major differences. But again, same basic formula, same basic setup. For us, the important part is two steps. One, plugging in the values into the equation correctly, and then using our scientific calculator to come up with a correct answer. And you'll notice here that I am modeling this with a TI-30X, which is the suggested calculator for contemporary college mathematics. We would like to know how much we're going to have in our account if we let our money sit for 15 years, compounding at this rate. So we are looking for our accumulated or future value. That future value is going to be equal to the principal, which for us is $2,000, times 1 plus the APR, which we are going to write 7% as 0.07, change it to a decimal, all over n, the number of compounding periods per year, because this is being compounded monthly, that will be 12. And then we are going to raise that to the number of compounding periods per year, which is 12, times the number of years, which for us is 15. When you plug this into the calculator, you want to do it all at once if possible. And you basically want to follow the problem along, including the parentheses. So that means that the first thing that you're going to enter into your calculator is 2,000. And then you're going to open parentheses, and you'll notice that those open parentheses are right here, right above the 8 key. Then you're going to type in your 1 plus 0.07 divided by, remember, the fraction bar really is a division symbol, so that's the way we're going to enter it into our calculator, divided by 12. Then we are going to close the parentheses. That's right here above the 9. And now we have to raise it to a power. When we raise something to a power, we use what is called the caret key. And that caret key is in the first column, 5th row. And that tells the calculator that an exponent is coming. But because this exponent is comprised of more than one number, in fact we have an operation going on here, we're going to want to put that into parentheses, enter in the 12, times, and then the 15. Close the parentheses and press enter, which is right over here on this side of the calculator. When you do that, if you have entered everything in correctly, you should get $5,697.89. As your future value. So what started off being $2,000 ended up gaining $3,697.89 in interest. To recap, first, make sure that you write out what you want to plug into your calculator into the formula. Then some people actually like to write out what they are going to be keying in, especially with the parentheses in place. That will become even more important on some of the problems that I'm going to show you in a little bit. But make sure that you enter everything in. Remember, you're reading this problem just like you would read a book from left to right. Enter the entire problem at once so that you're not rounding until the very end. Make sure you round your answer to the nearest cent, and you should be good to go. Our second problem having to do with compound interest, for those of you that use the Bennett and Briggs textbook, is number 65 on page 244. And this one is a little bit different, requires a different formula because it has to do with compound interest that is actually compounded continuously. That involves using E. E is an irrational number similar to pi in that it's a decimal that does not terminate, does not repeat. If you read in your text, you can see how E is actually determined, and we're going to be using it for our continuous compound interest problem. In this particular problem, we were asked to determine the accumulated balance after 5 years when we deposit $3,000 into an account that has an annual percentage rate of 4% compounded continuously. Just like the previous problem, we are going to begin by plugging in what we know into the formula. We know that we want the future value of this particular account, so we're going to set it up with A equals. Now we are going to, in place of P, put in our starting principal, which is $3,000. That is going to be multiplied by E, and I'll show you where that is in a moment on the calculator, raised to our annual percentage rate of 4% changed to a decimal, times the number of years that we're going to leave the money in the account, which for us is 5. That means when we plug this into the calculator, we are going to be putting in 3,000 times, and then we're going to need the E key. And to access the E key, I know it's a little hard to see here, but in the leftmost column, third down, you see a button that's named LN. Above that, you see very small e to the x. That's the key that we want. Now to access that, we have to first press the second key and then press the LN button. That will give us e to the x. So as soon as you press that, you're going to see E. You're going to see the caret key pop up, which remember in the previous problem I told you means that an exponent follows, and also for you will open a parenthesis. You then put in the 0.04 times 5, close the parenthesis, and press enter. If you have done that correctly, your answer should be $3,664.21. So once again, plug the information in carefully. Write it out a second time if you need to, so that you know exactly when you want to enter the parentheses and close off the parentheses. And then when you're done, make sure your answer makes sense. After 5 years, we're not going to make the kind of money that we made in the last problem. However, we should end up with an accumulated balance of more than what we started with. So if for any reason you don't see that happening, then you need to go back and check your values. Remember, always check your answers to make sure they make sense. Thank you for viewing this screencast.